Hello, everybody. Welcome back to another episode of Life the Complete Story. We are on episode 3 this week. Today, we are going to be finishing up our discussion on sponges, covering the last 3 classes: demo spongiae, the glass sponges with the weird name that I can't say, and
Hexactinellida.
yeah, that one,
That one.
and the Homo scleromorpha. As always, I am your host, Tyler, joined with my lovely co host, Alex. Uh, And we'll start today off, as we always do, with our Nature in the News. Alex
Yeah.
found this article for the week, and I'll let him kind of go in depth on what it is.
Yeah, so this article it's from the beginning of the week, March 26th, on Science Daily. It comes from some research from the University of Massachusetts, Amherst. They're researching a new emerging virus that is being transmitted through ticks. So I think especially like deer ticks, the ones that transmit Lyme disease and other diseases, called the Powassan virus. And they actually, uh, it's a improved way to detect the virus that's being spread by these ticks. So it's in the class of vector-borne diseases. So vector being something transmits it. Similar, like just like Lyme disease. So before they'd been using a method of testing that was kind of more like just your regular, like the traditional, I think PCR kind of looking for viral RNA in the ticks, but they have now developed a newer type of test. It's called a triplex real-time PCR test. So it helps. It's much faster, much more accurate than the former form of testing. It gives them uh, fewer false negatives and false positives, so it's way more accurate, as well as being out of when they look. This is up in the northeastern United States near Cape Cod and Martha's Vineyard. They of 819 ticks, they found that 33 of them tested positive using the
Did you
new
say
method.
Cape Cod?
Cape Cod. Yeah, that's what
Cape
it says on
Cod.
here. I think it's supposed to be Cape Cod. I was reading the article, so that's probably why.
I was confused.
Yeah, I was a little. It got me. I'm just gonna read the article, and if it's wrong, it's wrong. But this is so of those 33, and then they said 34 failed the quality control test. Um, so it kind of helps make and it said this is compared to the standard was the Luminex method, um, which said that those 34 ticks were found negative, but that method only found for 30 positive ticks. So it's one of those. The newer method is more accurate, it's faster. This disease, it's kind of one of those emerging diseases. It's called the Powassan virus because it comes from the town in Ontario, Canada, named Powassan. Um, Powassan, I think, is what it is. First identified in 1958, and it's just becoming more prevalent over the last 15, 20 years, to a point where there were up to, I think, almost 300 cases in 2022, and like 10% of them resulted in either death or pretty long-term neurological damage. So it's pretty serious to get, even more so than Lyme disease, because there's no treatment for it yet. So that's why they've been focusing so much on it. And this is with the way the climate is, more of these vector-borne diseases are becoming more prevalent because, especially in the northern United States, those ticks aren't being over the wintertime. Usually in the past, the extreme cold, especially the long-term cold that would be that was prevalent in the wintertime. You get a lot of snow, a lot of cold. It would kill a lot, especially the young ticks, those that really like weren't attached to an animal. Over time, it would kill many of them. But now, as it's warmer, those cold snaps aren't quite as long, not quite as intense. It's allowing more and more to survive, causing these, especially things like Lyme disease, has seen a pretty significant uptick. So then these other diseases are becoming more prevalent as well. But fortunately for now, it's concentrated in that southeastern Canada, northeastern United States, pretty fairly small area, but it could become worse over time. So that's kind of that nature in the news. It's a little combination of like public health, but also because it was those ticks and those viruses. Like we talked about in the first episode, viruses aren't alive, but because it involves the ticks. This is pretty prevalent because when we get to that point, talking about the arachnids, ticks are a very prevalent parasite um, that a lot of people are aware of because they are so widespread.
Right, absolutely.
So yeah, that's the article I got for this week. So now I guess on to the main lesson of today, talking about those last three classes sponges, starting in the demo spongiae class.
Right. So this week's topic, we're going to be finishing up our big discussion on sponges. Um, so the first class we're going to go over is the demo spongiae. These are the sponges that we used initially for our kitchen sponges. You know, they're soft, spongy because they're made of silica. Last week we talked about the calcareous sponges, who are more of a carbonate type material in their construction, but these are more silica, kind of softer in their nature.
And in some cases, they actually don't have any of those the spicules at all, which is why they were used for um,
Right.
kitchen sponges because you don't get that kind of sharp,
So
spiky piece.
so these demo spongiae, think of Porifera split up into two subsections, Siliciae and Calciae, I believe is what it's called. So the Siliciae is the silica sponges, the glass sponges and the demo spongiae fall into this group. Um, Most of the time, these are the Leucon body form. That's the most advanced out of the three body forms we discussed last week. It has all the little sub divisions inside of it that kind of allow more surface area for
The filtering of
the
the
filtering.
nutrients that they
They use
intake.
specific cells, but I forget the name of them. I want to say cyanocytes, but I'm not quite sure. It sounds right.
It sounds, I don't know off the top of my head.
And they use a monoaxon and tetraaxon spicules, so like a 2 point and a 4 point. Um, as I said, as we discussed last week, sponges came around in the Cambrian to Precambrian era, you know, roughly 500 million-ish years ago. But most sponge species didn't start to like have their big diversity branches until the middle to late Cretaceous. So yeah, some sponges. Most of the time, these sponges kind of bore into the substrate sometimes, uh, rather than adhering to it. They kind of
Okay.
they kind
So
of
they kind of anchor, similar to the way
yeah.
plant roots do. They kind of anchor in.
Well, these ones. This is a specific group in the class. So
Okay.
the next group down is called Clyonidae, and they use an acid to kind of etch out of the calcium carbonate that they kind of live on. So they live
Okay.
on shells mostly.
Yeah, like reef structures.
Yeah, reef
They
structures
break
and
bore into the coral structure that's been built over thousands of years by the coral polyps.
right.
And
Some
um,
other highlights in this class are the Zestospongiae with an X. They're giant barrel sponges, nicknamed the redwoods of the reef because they can live forever and grow humongous for a sponge. You know, we're talking upwards of 2,000 years.
okay, yeah, those are very old.
Right. In the article I used to research, that says about uh, 6 feet tall for a sponge.
Okay, that's very big.
But it's a more tropical sponge, Caribbean, Galapagos Islands, like how we were talking about
Yeah,
last week. This
typically tropical species tend to be larger
Yeah, because there's
in that
warmer
sense.
water, more
Yeah.
nutrients. And Dome spongia also has the group of freshwater sponges in the suborder Spongulina, um, and they can be found in any type of freshwater habitat, whether it's lakes in our hometowns, or rivers in the Amazon River, Nile River. I'd assume they prefer more sedentary uh,
Probably
places.
more, yeah, more that, or like when you get big rivers that are slower moving, like not
Right,
your Niles, your Mississippis, things like that. Not like you're not going to see too many of these in like fast moving headwaters that have really cold water.
right. Little news article I found. Um, Back in 2005, there was an outbreak of eye lesions in Brazil,
Hmm.
and these were because a freshwater sponge uh, was unable for its young. I don't want to say a larval stage because they don't really have a larval stage,
Yeah.
but that early stage that's trying to find its sediment to grasp onto, couldn't find its a grasp because of an invasive clam. So they weren't finding the spot to hold on, and they just die, and their spicules would be just spread throughout the water because it's dead,
Hmm.
which would cause these young kids who were playing in Brazil
Uruguay.
river.
Oh yeah.
It's in Brazil. Um, so these sponges are disintegrating, and all their spicules are floating in the water, which is causing these eye lesions in these
Okay. Yeah, I mean,
individuals.
it'd be similar to getting like sand in your eye over, but like really, really fine sand.
Right. Um,
Okay.
and as we talked about last week, this group also has the carnivorous sponges that Alex kind of alluded to,
Hmm.
who kind of traded in the choanosite is the word, not cyanosite. Choanosite.
Choanosite. Okay.
Um,
Yeah, coanosite. Yeah.
that's their filter feeding system, and these deep water sponges have traded in that filter feeding for more sticky gluey substance instead to
Hmm.
capture their prey.
Okay.
Um, I will give a quick screen share for video listeners at
Yeah.
home.
So they kind of look almost like the way a sundew plant does, where it's got like the long fingery
Yeah,
structures that,
Velcro.
yeah, basically you can see on the that bottom right picture the little, almost looks like the little globs of like the gluey substance.
Right.
Yeah, and I mean you can see they're very small. I mean even most of them like that 10 millimeter
Yeah, that's about the largest one. I mean,
size. Yeah, they're
it's
they're
still
not very
probably about
big.
30 millimeters across with that big fan on top of it. But
Yeah, but
um,
you have to think that's only, it's not very big. Size of your hand maybe.
yeah,
Um,
here's these freshwater sponges I was discussing earlier. We kind of alluded to in the first week about sponges.
yeah,
The giant barrel sponges, that live for hundreds of years, can grow up to 6 feet. That one in the middle's huge.
that
That
is
looks like that diver can
massive.
fit inside and sit down and have a nice picnic.
It does, yeah. And then when we're looking at the freshwater sponges, I will be corrected
They
because it
almost
said they've
don't
even
look.
found them in like alpine water bodies, so like those high up, like really cold water. They're
Yeah,
probably very small. Like you see, the one almost looks more like a
it's like
moss
an
or like an
underwater
algae.
moss. Yeah,
Yeah, it looks more like an algae. It's very
and
very
this
small.
is this is that redwood of the reef again, another barrel sponge. These are the ones that kind of bore in. See how you can see. There's not much on the surface, but I'm imagining there's
There's a
probably about 2 or 3 inches into this rock or shell or whatever it is, um, of this sponge body.
Yeah, I would only imagine it because usually, especially like that in those reef areas where you get uh, a lot of like wave action, they would need to hold on pretty
Right,
tightly.
like the tidal pool area. And as I said, a
Yes.
leucon body formed with all these little subdivisions to filter through and get more nutrients, supports a bigger body, and their spicule shapes. Without further ado, we'll move on to our next class, the glass sponges, hexactinellata, close enough.
Yeah.
Um, Once again, they're also silica sponges. They can have a like I don't know why I'm here. We go. Let's get some pictures, not our little script
Cheat
there.
sheet. Yeah.
Yeah, a little cheat sheet. We'll go on to the hexactinellata.
Okay.
These are found in deeper waters. I think from about 200 to 3,000 feet is what I read
Oh,
off
okay.
of this
So those
article here.
you can see why they don't really have any. At least the picture shows the one
Yeah,
doesn't have a
there's
lot
not
of
much
color
color.
because it was a super deep ocean.
And I think that's kind of why they get their name, glass sponge, more translucent,
Hmm.
even though they still have the same, like, chemical makeup as the demo sponge ape.
Yeah.
They have a Cycon and a Leucon, so they're more advanced, as well as the simpler but not too simple, where it comes in from the sides, from pores on the sides still, on the choanocytes are all these little red spots.
Yeah. So in
Because
that, it looks like the Cycon. It's like um, there's really only one chamber at a time but it's a more advanced chamber. There's more surface area, but the Leucon you get like almost multiple chambers of the filtering cells before it dumps out. So there's a lot more chance for it to filter out the food and things that it's trying to take in.
yes, and they have it almost exclusively. Sorry for me jumbling my words there. This hexactine spicule, so 6 points off the spicule, 2 main points as well as four little smaller points. Um, like I said, I don't want to say restricted, like they say in this article, but it's more
Most prominent.
exclusive, most
Yeah.
prominent, yeah. But the more extinct species, those fossilized remains, we've seen globally, we'll say.
Okay.
Uh, there's even some species of these glass sponges that use kind of like a mat or a rope, so they can kind of like adhere to more muddy substances.
Yeah, those deep
That
sea surfaces it's a lot of like that fine silty kind of sand
right, there's
and
no
like
rocks per
mud.
se
Yeah.
down there. We got some. This black and white image is a SEM microscope, scanning electron microscope, of one of their microsclers. So basically, the makeup of these spindles.
Okay.
Again, originated back in the Cambrian 500 million years ago, but didn't really hit their full stride until the Mesozoic. And now, as we're kind of in this.
They seem
Uh,
to be compared to the other sponge classes. They seem to have been hit pretty hard by the Mesozoic extinction.
yeah, the Mesozoic extinction, just extinctions in general. Each because there's Cambrian extinction, Ordovician extinction. They basically drop down too.
And I'm sure a lot of that would be like those uh, more surface kind of level species of this class of sponges. I'm sure they would have been hit much harder than say like even like the calcareous sponges. That and you said Demospongia has a much larger group, so
Right,
it had more to give, kind of thing. When it
like we
was,
said, there's what almost 10,000 species of sponges
I think
last
so.
week, and 8,800 of them are from Demospongia. So we're saying that between the other three classes, calcareous sponge was covered last week, and the other two, that this one and the one we have to cover yet still has 1,200 species combined.
Hmm.
Yeah, yeah. The bounce back is harder for them. But glass sponges have been found to make some of the largest sponge reefs. Uh,
Okay.
that's references here about bioherm heights of up to 19 meters. So I'm assuming that means the largest point of this reef is 19 meters tall.
Okay. Yeah. So it's just been built up to that point of all the
Yeah,
different sponges and things.
where certain points of this reef have been alive for 9,000 years. This is
Very
from a
cool.
2001 article.
Okay.
Other than that, mostly what we have for glass sponges is we're kind of using the construction and of the sponges, the 6 point spicule, to kind of use in modern architecture. It's a very strong construction type. It's almost like triangles are super strong in engineering.
Oh
Uh,
yes,
so
absolutely.
we're having a 6 point spindle makes a lot of triangles whenever you put them together. Very, very strong, honeycomb
Absolutely.
almost looking material. A couple more pictures of some sponges. A vase sponge with a shrimp inside. See this little white speck?
Yeah,
That's your shrimp. I mean, they have some unique shapes too.
they do. Yeah, you can
Um,
see that kind of rope structure you were talking about.
yeah, it has a stalk that lets it kind of grow off the silt and have a nice bulb at the top to gather
Yeah.
all its stuff. A lot of them aren't common named yet, just because they live so deep down. We're still exploring this deep, deep ocean, so getting a common name isn't exactly top of the priority list. Let's make sure we cover our bases and find them all before we start naming them.
Hmm.
Um,
Absolutely.
and that brings us to our last group of sponges, the Homo scleromorpha, which is actually the newest um, class of sponges. It used to be within the Demospongiae class, but you know, research is groundbreaking all the time, finding new, improved ways to research. We're finding out that these are a different makeup than the Demospongiae and having a uh, more unique structure than them. So we kind of gave them their own class.
Okay.
Uh, my bad. I lied whenever I started this. There's three groupings because Homoscleromorpha and Calcaria are their own separate ones in themselves. And Demospongia and Hex, I read the tree wrong.
Yeah. Well, they're four separate classes. It's just like
Yeah, it's like a
how they.
super class is
Yeah, almost.
Silicia.
Yeah.
Um, Once again, that Leucon body form. You know, as we're seeing more modern, these modern sponges have really advanced to a peak of the best way to filter feed. They use this Tetraxon spindle, and as we saw with the pictures of the demo sponge here, how they're more tall barrel type shapes. These homoscleromorpha are smaller to the ground and kind of are like a moss, where they rather be short but spread out over a couple meters than grow to those 4 foot heights.
Yeah, and that's a little higher up on the article we're kind of running off of here. It said that because they stay so small, their fossil record's very bad, which is probably why it wasn't until more recently that they became their own class of sponge.
Right. Really, the only way we could. I'm mixing up my articles here. Demospongiae, the most prehistoric Demospongiae, um, we found off of not fossil records, but steroid markers in like hydrocarbon markers
Oh, okay.
in the rocks that are similar or identical to modern sponge steroids. That was just kind of making the assumption that hey, if they exist back then, that's probably a sponge.
Yeah,
Um, they have some bright colors as I'm seeing in these pictures.
they do. Yeah, it
Um,
looks like of these two major families that are in this class, one of them is actually doesn't have spicules, so it's probably the ones that are a little flatter, more like that kind of mossy size, and then the ones that are a little more upright, kind of little wavier, have more structure to them, are that other family.
this is newer within this century, within the 21st century. They've been kind of separated. I believe what 2002, 2005, somewhere between them is whenever they were like officially identified as their own class.
Okay. Yeah, and it's saying here, at least as far as the fossil record is concerned, they only have fossil record back to the Jurassic period. So, I mean, 100 some million years ago, but that
Compared to
compared
the
to the
others,
rest of the
yeah,
sponges, that is incredibly recent. That's a couple 100 million years ago compared to almost 1,000 million years ago.
but that wraps up my lesson for the day. Um, we'll move on to our two recurring segments. Alex, if you want to take it away for your most wanted for the week, I know we
Yeah,
got a doozy.
yeah. So our nature's most wanted for this week. We mentioned it last week in passing. So I wanted to focus on it more today. Is the emerald ash borer. It is an insect. Seems to be a pretty common theme for a lot of these invasive species. Insects tend to be a lot of them. Um, Native to kind of central East Central Asia, so like Eastern Russia, Northern China, Korea, Japan, that area. Most likely imported from Asia in cargo accidentally. Early 2000s, late 90s is when it came. But what they do is they burrow into the larvae. Correct me. Um, Burrow under the bark of ash trees. So there's a in the Fraxinus grouping of trees. Uh, what they do is they make they as they burrow they mainly in that cambium layer into the cork cambium, like right at that edge where the bark and the living tissue of the tree, like the actual wood of the tree, are. And as they burrow through there, they make a whole lot of these tunnels that eventually pretty much just girdle the tree from the inside because they eat through that living tissue to feed on, and then this doesn't let the tree transport water, nutrients, things like that would keep the tree alive. So very quickly you see, in a lot of cases, especially trees that have been affected by this, they die pretty quickly and the bark starts to fall off. A lot of times in dead trees, the bark will fall off just because it's not producing the new bark to replace it. But it's especially quick with your ash trees. This has been a pretty significant impact on trees in the eastern, midwestern United States, Canada, uh, that area where those deciduous forest areas where you would see um, a lot of ash trees as part of the forest ecosystem. So I'll bring up and share here. This is what a adult emerald ash borer looks like. Um, there it is, fanned
Very
out.
bright
Yeah,
colors.
they say emerald. They're not kidding. They're very bright green color. Um, but it is something that we said here from China, probably in like wood packing materials, things that were probably wood that was imported from Asia um, to the United States. And let me pull up some more pictures like of the larvae, if I can find, or damage that was done to the wood. So here you can see kind of where the larvae, as they tunnel through the wood, they leave these little tracks in here. Here we go. So you can see here these small little holes that are left in especially these like kind of D-shaped, kind of half semicircle holes are a good
Where are you?
indicator. Whoop,
Your
sorry.
screen is
Yeah,
not a
I
sharing there, bud.
apologize. I was showing the wrong screen. There we go.
There you
So
go.
these like half semicircle shaped holes coming out. You see it. This is a lot of what that wood underneath will look like. Um, all these tracks running through that. There you go. Because that's a good show. And that looks like an adult that's about to emerge. These tracks. That's a really good example. You can see how, and when you get a whole bunch of these larvae that feed on trees like this, it just a couple years it'll kill the tree. I mean, they're just, and it's rather difficult to keep them from moving. I mean, there have been things like wood transport bans, like if you to keep try to prevent the movement of this invasive species, but it's just incredibly difficult to control here to the point.
Yeah,
You can
yeah.
see the example of trees. You'll see this crown dieback. That's within a year or two. and then within a couple years after that, it starts like this bark just peels off almost like a like you peel like
Like
a
a sticker.
yeah, like a sticker, like how you'd peel like a banana. It just, you can just pull it off and it's just barely on there. And it's thousands, if not millions, of trees across the eastern United States into Canada have been affected by this, and has really put a serious damage. It's caused a lot of damage too, especially to things like um, utility structures like power lines, because you get all these millions of dead trees. A good number of them are close enough to the power lines, and it's just because it kills them so quickly, they break down quickly. Usually, ash trees, because it's a somewhat harder wood, breaks down from the top. But those trunks that are left have a very high tendency to just fall. They don't necessarily break at the trunk. They more likely fall over, which causes damage to homes, roadways, pretty much any sort of structure that's close enough that it could be affected. And unfortunately, too, this wood is not able to be reused for things other than you could burn it maybe, um, because it makes it very brittle.
Right.
So yeah, that's emerald ash borer. If you find it in the wild, squish it. If you have an ash tree on your property that's still living, if you're able to get to it before the ash trees do and kind of keep it alive, good job. I've seen a couple very large ash trees that people were able to kind of do their best to treat and keep them alive, and they're still in good shape. But it's one of those, they just have to keep on it, because otherwise it'd only be a matter of time before the borers get to them. And it's all like species in that Fraxinus um, family. So like green, white ash, black ash, all kinds of everything in that family group. Which, so yeah, that's that ash group. It also affects olives and lilacs, but the biggest parts of the group are your ash trees. That's your English name. Um, Fraxinus is that genus name.
Big problem. Big problem.
Correct. Yes, it has become a big problem, and I mean, say it's only 25 years since it's been introduced, and it's killed so many ash trees already that it really hasn't
Right.
slowed down. And of course, the native ash trees in Asia have developed ways to combat it. Either they produce chemicals, or they have thicker bark, things like that, to keep them alive. But the ash trees of North America do not have these defense mechanisms, and it just has been wiping them out. So that's our most wanted for the week, and I will go to our last section of the day, which is our amazing species. As a species from the IUCN Red List, so it's some form of endangered species. So what do you got for us this week, Tyler?
This week I have prepared not a sponge. I learned my lesson last week. But yeah, this one is the painted terrapin. Scientific name Vatagur. So they are critically endangered, which means that. Give me 1 second. The
They're
IUCN
very
actually
high on.
has like guidelines on how they distinguish. So it's like critically endangered has like less than a 30% chance to survive in the wild without human intervention. So yeah, they're critically endangered. Assessed in 2018.
They're
Um,
very colorful.
they are very
I'll,
colorful,
I'll pull up the picture
beautiful
for you.
shells. Um, Beautiful shells, nice red striping on the front
Yeah,
typically.
yeah,
Very beautiful.
that's the turtle we're talking about.
It almost looks fake
Yeah,
from the
almost. Yeah, so the painted terrapin native. Yeah, so I'm sure you're getting there. That
right.
southeastern
Southeast
Asia.
Asia, Indonesia, Malaysia, Borneo type area. They like to live on the coastline and the coastal forests, as well as um, like the intertidal regions, where it's brackish water, kind of shifting from freshwater to saltwater, them estuaries and other types like that. Um, They are in the genus Batagur, which is kind of like other terrapins, a lot of Indonesian turtles, things like that. Don't worry, a lot of them are critically endangered. Just how it goes.
Yeah, unfortunately.
Yeah, assessed in 2018, March 12, 2018, which they've been critically endangered since 1990.
Okay.
They've been on the list since 1982 and have slowly gone from vulnerable down to critically endangered.
Yeah, and looks like on the map they live kind of in those in what looks like those coastal areas that wind up being more developed, like here on in Malaysia near like Kuala Lumpur, Singapore,
Singapore, right?
Georgetown, a lot of those areas, and then over into Indonesia, um, a lot of those coastal areas that have a lot more developed. Uh,
Yeah, the species. The ICN has noted that it's suspected that there's been an 80% reduction in the last 3 generations, which is a lot. You're
yeah,
taking,
that's
you're,
pretty significant. Looking here, it's at a generation length is about 45 years, so
yeah,
that's not like one individual can live around that length, give or
right. So
take.
we're saying that's within like 150 years. So we're talking late 1800s. Uh, the population has decreased by 80%. They're decreasing still. Critically endangered, as we know. Um, Really, their biggest threats are us.
Yeah,
They don't really have any invasive species that are really pestering them in their habitat. It's a lot of uh,
pollution.
farming,
Yeah.
farming pollution, mining pollution, fishing, getting caught in nets, I'd assume,
Hmm.
just garbage and trash all over, as well as your normal climate change.
Yeah.
Uh,
Yeah, it looks like here going through the red list site, they are used in like the food and pet trade, which is something that, especially in larger animals and especially in reptiles in that Eastern Asia area, is very a lot of like traditional medicine, traditional food consumption is something that they get caught in a lot.
yeah, a lot of the times these reptiles they take the eggs, and
Yeah, it
that's
looks like
that's
yeah they're taking the eggs, as well as um, because it's so colorful, it looks so nice that people are keeping them for pets. Um,
right.
not
Although
as
that's
much
not so much in Indonesia, but in the
the
more
international.
or less here in America, a lot of people want those exotic reptile pets, and then they can't take care of them, and they kind of just get
Yeah,
thrown out.
that or they become so popular they start capturing them, and it's just they can't
Yes,
replace something like this. It can't replace itself fast enough.
right.
Especially once
Um,
you start removing a lot of the eggs and a lot of the adults at the same time, it snowballs.
right. So it appears that their like cycle is they live in the forests, but they go to these brackish water beaches to lay their eggs in the softer sand.
Okay.
Um, with more research needed into really their their lifestyle and how often the cycle occurs and everything. But we have site protection for these beaches that we know they lay eggs on, these forests that we know they live in the regions that we know they exist, and there's laws and policies in place all the way up to an international level for
Okay.
them.
Yeah, they are in that international protected level because they're so. I mean, usually once you get to the endangered, especially critically endangered, they start
The world
really
starts to
paying.
notice.
Yeah, they pay very close attention.
Right. Very beautiful animal. Uh,
Absolutely. Yeah. I mean that color, that nice light gray with the red stripes is beautiful
right.
looking turtle.
Um, I wish I had more to talk about here, but I really don't. Yeah, we don't have a set number of individuals. They're not. We don't have like a banding process or anything in place for them, like we do for birds or tags for fish like that. So we're kind of just up in the air. Oh, let's hope we can save them because
Yeah.
we need some good in the world. Would you? Do you have anything else to add, Alex?
I do not right now. This
Okay.
is so I kind of trying to figure out for the listeners here what we're going to look at for next week, because we went through our sponges, so we went through the
I
Phylum
believe the
Porifera.
next most basic so move
Be
would be the Nidarians,
Yeah, I'd say either
correct?
Nidaria or get into the worms, maybe.
Ooh,
Um,
the worms would be fun.
but
I feel
so
like
we'll stick with because we talked about them a lot. They live very close together. We'll go to the Nidarians next for
right.
our
A little preview on the Nidarians. That's going to
yeah,
cover the corals as well as the jellyfish,
sea
correct?
anemones,
Sea
hydroids. Yeah,
urchins, right? Or urchins,
no, urchins are
a kind of
mollusks.
mollusks.
That are their echinoderms. They are not Nidarians. So yeah,
Right.
just to get a little sneak peek for next week. Slightly more uh,
Advanced.
advanced, but not too much yet. We'll probably get through them, and then
We'll probably take
our
another two
our
weeks to go over
worms.
them, I'd assume.
Yeah, yeah. We still have a little while before we get to the more advanced ones.
The fun
So
stuff.
don't worry. It'll be a
Um,
minute yet. That's okay.
Little update on the rest of our the, the moving pieces that we have going on. Expect us to have uh, our
So
Instagram and Facebook pages up for the show within the next week, I'd say.
yeah, yeah. Fairly soon. We have to
Fairly
work through
soon.
yeah.
Before we get to worms, probably.
Yeah, that'd be ideal.
But once again, as I said last week, if you have any questions, opinions, anything you want to bring up to us on the show, feel free to email us at lifecompletestory@gmail.com, correct?
Yes, sir. Absolutely. Yeah, we'd love to hear some questions or something that we talked about that you want to hear more about. Please let us know if we start getting some more get enough that we can actually do like an episode of a Q&A episode. That'd be awesome.
Right? Or even maybe that's something we do on our social media pages is like a Instagram live or something like that,
Yeah,
where we get
absolutely.
together, you and I, because we little fourth wall break. Alex and I live on the opposite side of the town from each other, so
Yeah, close
there's
enough.
yeah, it's not like we have to plan a whole weekend trip of let's get together, do a Q&A and everything. It's just, hey, we got like a backlog of 20 some questions. Let's sit down, crack a
Bust a few of them
brewski,
out.
and
Yeah.
answer some questions.
But absolutely. Well, I think that so yeah, next week start into the phylum Nidaria. So
Right.
little preview for next week. So other than that, I'd say that wraps us up for Porifera. At least we talked
Right.
through our
One
four
file
classes
them
of
down.
sponges. So that's one phylum in the kingdom Animalia.
Yeah.
So
8 more to go.
oh yeah, getting there. So it'll be a little. It's just going to be an adventure for sure.
Right.
I'm absolutely I'm excited to say the least. But yeah, well, I appreciate everyone listening, watching. Stay tuned. Every Sunday at 7 o'clock, we got a new episode coming out.
Right.
Um, so far we've done pretty good on our YouTube as well. You can watch.
Yes.
I think I'm not sure if you can watch on Spotify or not, but I know you can on YouTube. Usually
Yes, the
the
YouTube the video is up on YouTube a week after it launches on Spotify. There is video for both. Um, that's I listen to our podcast on Spotify, and I know that we have video for it as well as just audio. So keep that in mind. As I said, we launch our YouTube videos a week after they show on Spotify. So whenever this episode comes out on Spotify, our intro to Sponges will come out on YouTube.
sounds good. Well, thank you, Tyler, very much. I think it's been a pretty good episode, and I'm
Absolutely.
looking
I
forward to next
thank you
week.
for
We get
joining
into
me
it
again.
always, always, and thank you, listeners, for joining us and working through the tree of life with us as we try to fill out a little more of this story that we're
Right.
looking to tell. So yeah, absolutely. I think that does us for this week, everyone. Keep learning,
Onward,
keep
keep
learning
learning.
something new.
There you go.
Absolutely. Thank you all.